good morning. Hope everyone's doing good, enjoying the conference. Over the past few days, I've met a lot of old acquaintances from the Drupal community, and when they saw this title, Reaching the Cloud by Standing on the Shoulders of Giants, I got the same question multiple times. So, Wunder is now doing commercial hosting products. And it's like, actually, no. We are not launching a new hosting product. Well, there's a few reasons for that. First of all, we already have our own internal hosting that actually works quite well. It's based on Ansible and hosted mostly on UpCloud. It's stable, it's effective, it's secure, it's battle-tested. We use it internally for clients, but yeah, it works. And the other reason, well, actually, we're not a hosting company. The value that we provide to our clients actually comes from the relationships that we build with them. The work that we do over time to build solutions, to conceive solutions, build solutions, and then actually have those solutions evolve over time. But we're not a hosting company. However, we need to do hosting. Well, hosting is an essential tool. I mean, you can't build stuff and not put it somewhere. So it's really an essential tool. And the reason why we need to do hosting, it's not because we want to, but we have, over many past years, pretty much since the company existed, we've been looking for a hosting partner that would actually meet our requirements. And unfortunately, and we've looked quite extensively, we haven't found the right match. And so the reason we do hosting is because we need something that works for us. So what is it that we were missing from the hosting that's available out there? I mean, it's a crowded market. There's plenty of solutions. So what is it that we were missing? First one is we were missing the flexibility to use exactly the right tool for the job. We were early adopters, both of Drupal 7, Drupal 8, also new technologies like Elasticsearch, also doing some pretty cool stuff with React and Node.js. And there are many solutions that were tailored for Drupal, but then those solutions were actually tailored for Drupal and only Drupal. And we want to have the flexibility to use new technologies, to try out new things. And also sometimes it's mandated by client requirements. We do a lot of work in the government sector, for example, where we just need to stick to specific guidelines. So we really needed to have that flexibility. Also, the type of project that we do have a pretty wide range of variety. And sometimes the standard hosting packages that you get are not well suited for this type of work. For example, a website that is built using a static site generator, it will need a lot of resources during the build process, but actually the hosted site needs pretty much no resources at all. And so if you go with a small package, then you have really slow build process, which is really tedious during the development process. But at the same time, if you go with something big, you really end up with something that's overkill in terms of running instances. So we really wanted that flexibility. Same thing with storage. We have one client for whom we're building a very interesting data analysis platform, storing like terabytes of data. And at the same time, this website only has a handful of users. No need for a high availability solution, no need for like very beefy servers. We just need a lot of data. And with the pricing models that a lot of hosting companies have, this just ends up really expensive. And yeah, so we really wanted to be able to invest money in those places where we want. Also, well, we have 150 people, a lot of different teams. We really wanted to have processes that work with the teams that actually support the way that we work together, a strong agile mindset, really collaborative processes, and a lot of processes that came with hosting platforms just didn't fit what we wanted. And last but not least, we wanted transparency. The relationship that we build with our clients are all based on really like being open, transparent, sharing the work that we do, when we make mistakes, and we do make mistakes, we tell our clients. And we've actually had difficult times with hosting companies that, well, the site goes down, yeah, maintenance went wrong. But nobody actually saying, hey, we're sorry, we made a mistake. It's no big deal. Everybody makes mistakes. But we want to be transparent in our communication about everything that affects the sites of our client, the projects of our client. And if the hosting partner is not playing along with that transparency, we actually end up with a problem. So these hosting solutions actually provide a lot of great things, but actually many of those things we don't need. So for example, we don't need hosting for everyone. We don't need to compete with shared hosting. We don't need to have a fancy marketing page where you can just put your credit card in and just get quick access. This is not something that we need. And there's actually a lot of complexity related to all this, the billing and all of that. We don't actually need to have this into our hosting platform. We also don't need a fancy UI. We know our users, developers, we have some very good idea of what are the skills that we can expect from our own developers. And a UI is actually a good thing. Having the right tools, it's actually a good thing. But we don't need something like fancy drag and drop that will impress in terms of marketing, but that won't actually bring value. So we want a tool that gets the job done. We also don't need cost-based invoicing, the whole billing thing. It's just really complicated to do correctly, especially when you have dynamic resources. We also don't need to specifically push and sell our hosting infrastructure. This is something that we do as part of our regular sales and marketing efforts. So we don't need to sell hosting as a product. But what is it that we want? And this is actually a list that we made more in the mindset of what is the solution that we want compared to the stable hosting that we already have. The first thing is we want modern technology and processes. And Ansible, it works great, it's battle tested, but it's not exactly the most modern technology. And one of the things that we were missing is really related to the processes. And with the processes, what we want is actually faster innovation, experimentation, really giving our tools the possibility to just create new servers with new setups. Hey, you want to try out RabbitMQ? Go for it. Give it a try. And having this kind of solution that enables experimentation, container-based environments are great for that. And that's really this innovation, possibility to innovate and to integrate that innovation as part of our agile development process was really key. So we don't want to have to ask for support to say, hey, could I please have a server with the alpha version of Elasticsearch because I want to try out something. No, you just do it, and you really want to have this quick process. Also, our business is not hosting, and so we can't really justify spending millions of euros into a hosting infrastructure that will be fully built from scratch with our own famous orchestration engine that somehow is going to be better than everything that's out there. No. So we really want to stick to this concept, proudly invented elsewhere. We want to reuse as much as possible and do as little as possible on our own. We want to do it in the open. We want to share, but we don't necessarily want to spend a lot of time rebuilding things that already exist out there. So also it should be self-service. And when I say self-service, it's not the same kind of self-service that you get with a lot of hosting companies where you can really register with a credit card. This is really meant for our developers, that they should be able to create new environments, create new branches, do all of this without any assistance. We have a very good ops team. They're great, super competent, but I don't want them to spend their time provisioning servers for other people, because no matter how quick they are, they're not going to be able to react as quickly as someone just pushing some code or pressing a button. Also, it should be simple and flexible. And this is a bit of a contradiction, because if it's too simple, it's not going to be flexible. If it's too flexible, it's not going to be simple. And I think that this is the part where we need to have a good understanding. Where is this sweet spot for us? And this is something that's going to be different for different organizations. How much control do you want versus how much simplicity do you want? I feel like we have a good idea of what we need for us, but this is something that will change for every organization. It should be technology agnostic. I mentioned already a few technologies besides Drupal, and we know that there's going to be more things to come. And we don't want to treat everything like a Drupal project with a bunch of add-on technologies that come to the side. No, each of these technologies actually plays a key role, and we want to really embrace this microservice architecture where we have multiple systems. Sometimes you even have multiple Drupal sites that are part of one single project, and really having the possibility to have an infrastructure that really represents all these technologies. It's really important to be able to innovate, to try things out. It should also be infrastructure agnostic. We have clients who require us to host everything on their own AWS account. We also have clients who refuse to host anything on AWS. We have clients who don't care. We have clients who have on-premise infrastructure hardware. So we really need to be able to address all these different scenarios and help our clients in all these different scenarios. And finally, it should be reliable and transparent. Reliable because, well, we actually want to build something that's not only for development processes, but also for production hosting. And it should be transparent because, well, we don't want to have a black box that only a few people understand. We want to have a system where if something goes wrong, and that happens, that people can see what is happening. We don't want to hide anything. So we really want to be transparent and make everything accessible so that you have an infrastructure that's easy to understand, and that if you want to look under the hood and see what's happening, you actually can. So how we approach this pretty challenging list of requirements, actually we decided let's combine a few different tools, some of which we know, some of which we don't know that much, but each of the parts of a hosting infrastructure, there are very good solutions. And by piecing together different solutions, then we can actually build something that's pretty great. The problem when you have like a little bit of GitHub and CircleCI and this and that, then you end up with like a lot of different technologies. And we needed to have a way to talk about this thing, so we gave it a name. We called it Silta. And no, Silta is not a commercial product. There's no place where you can buy Silta. It's not even like a repository on its own because it actually comes from the combination of multiple things. And if anybody wonders, Silta is actually the Finnish word for bridge. And that kind of represents what we were thinking of in terms of like building this architecture. We actually want to have something that bridges the whole experience together. So what do we have as part of this stack? First component is, well, pretty important one, GitHub. Don't need to introduce GitHub. I think everybody knows GitHub. We already use it as a standard for us. It's kind of the industry standard. Like the UI is really fantastic. I mean, GitLab and Bitbucket are also getting better, but it just has that extra level of polish. Also has plenty of integration with other systems, and it's a hosted service, so we don't need to care about maintaining that service ourselves. Well, we want to build software projects for our clients. We don't want to spend our time maintaining a Git servers. So GitHub, and then we connect GitHub with another hosted solution, CircleCI. Who here is familiar with CircleCI? Okay, handful of people, but I guess many people are probably familiar with Travis, which is used pretty widely for open source solutions, used for testing. And CircleCI is actually a bit more advanced in that it lets you provide your own Docker image that you use to run your build process. And that also means that you can really use whatever tools you want, and you can, with a custom Docker image, you can say, for example, we want Drush. That's available by default. We also want to have PHP-CS installed by default so that we can validate things in our CI build. And having those things just like pre-installed for every build actually makes this a lot more faster, because with Travis, for example, whenever you run a build, the first thing you do, you install PHP, you install Drush, you install this and that, and so you spend the first 1.5 minutes of your build process actually always doing the same thing, which is just getting the tools that you need. So at this, like the first 1.5 minutes, you're not doing anything useful. And with CircleCI, we can actually make this faster, and there's also an excellent caching mechanism so that you can, for example, you can cache all your vendor dependencies from Composer, so that if your Composer log file has not changed, you can just like reuse the same ones that are there. That means that we actually have the possibility to have builds that perform in like under 1 minute, which is, yeah, you don't want to have people waiting for the builds to happen, because an infrastructure that's too slow or a continuous integration system that's too slow is one that kind of gets ignored. Yeah, and then the next one is probably one that's less familiar, Kontena. So Kontena is a container orchestration solution that's really aimed to make it easy for developers. It's simple, it's still quite flexible, and it's pretty much everything is based on an API that lets you interact with your cluster, and it has really a good concept of stacks. A stack is like a way to represent an application where you have the different parts, different services that you need. So for a Drupal stack, for example, you would have Nginx, you would have PHP FPM to run the PHP code, you would have a database, and you could eventually also have Elasticsearch or additional solutions like that. And yeah, there's a very powerful CLI that actually lets you create a new stack, instantiate a new stack, and so on. So it's an open source project. It's also a hosted service. It's actually going to disappear, but I'll get back to that later in this presentation. We didn't know that when we started. And also it's cloud agnostic, so you can host it anywhere. Some people are maybe wondering, what about local development environments? Actually, for local development, we use Lando. It's a good solution. It works good for us. Works well for us. It's actually we use it on existing projects. We can use it on new projects that are hosted on this new infrastructure. And yes, it means that we don't have an identical local setup to what we are deploying. But based on the fact that we have the possibility to deploy any branch that we want, it also means that we have the possibility to have a proper review of our code in a deployed instance before we merge anything back in the main branch. And so that means that actually it doesn't matter that much that we have some slight variations between our local development environment and what's deployed. And it's also technology agnostic, so it's not limited to Drupal. So how do we put all this together? So the flow is pretty much as following. So as a user, I push to a GitHub repository, and this GitHub repository is actually part of our own organization. And this is essential because it means that we can have all the credentials that we need to connect to the different systems that we need. All of them are limited to our organization, but they're also available by default in CircleCI. So that means that we don't need to set up the credentials for a new project. Every project that's part of our organization has the capability to be deployed. Then we enable CircleCI, and with CircleCI, the only thing we need is actually one YAML file that's going to be in the repository. And it just describes in pretty easy language, and CircleCI actually has very good documentation. It describes what are the steps that you need to do to run things. And the first step is going to be the validation step. There we run PHP-CS to check for coding standards and obvious mistakes. We also use ESLint. And that makes it possible to just provide really, really quick feedback before we do any build or anything like that. So if you want to provide feedback to your developers, don't do the whole build process and then at the end say, oh, by the way, you're missing some white space. You actually want to provide that feedback as quickly as possible. Second step is the build process. The build process, well, we run Composer install, we run Yarn install, We build the front end with Webpack, these types of things. So we build the code base, and then once we have this code base that's there, that's complete, what we do is we build custom Docker images that we push to a repository. So we push one image for the Nginx container, one image for the Drupal container, and what's interesting here is that we have the possibility to determine what goes in and what doesn't go in. So for example, we don't need all the PHP files that make up a Drupal installation in the Nginx container. And so we explicitly exclude those so that, well, we get better bandwidth usage, but it also means that it's more secure because we don't have anything that's there that shouldn't be around. So now we have our code that is existing in Docker images that are in a repository, and we're going to deploy this. And the deployment step is actually using the Kontena CLI to talk to the Kontena master, and it's actually using another YAML file that describes the stack. So what are the different parts of my application? And in this stack, we did, like the default stack actually, it provides, the images that we just used. So the Nginx image with our code, the Drupal image with our code, the database and Elasticsearch and other services that we want to integrate. But for those, actually, we don't need any project-specific code, so we use the standard image. And what's interesting here is that we can push everything to a specific environment that is named based on the project name and the branch name. And so we get a dedicated environment for every single feature branch that we create. And that makes it possible to just, hey, you want to try something out, create a feature branch. If it doesn't work, that's okay, delete the feature branch. And so this really makes it very easy to try things out and to make sure that you have things working before you merge anything back into the main branch that you share with the rest of your team. And then once we have this stack that's been deployed, in CircleCI, we just output a small message that says your site was deployed successfully, and here's the URL, and here's the basic auth protection. So we actually have, like, for the user, it's possible to just push to GitHub. Based on GitHub, we see the status indicator that links to CircleCI, and CircleCI has a link to the created environment. So actually, we have different components, but they're all tying in together quite nicely so that the users can just follow what's happening and go from one place to the other. And in the end, we can also run integration tests against each of these dedicated environments for each feature branch. So what do we get out of this? Well, first of all, it's simple. We have 2 YAML files, and we provide a default template for Drupal sites. So that means that if you're doing a Drupal site, you don't need to do anything. It just works out of the box. If you want something that's a bit more complicated, that has maybe like more front-end components and so on, you need to modify that slightly, but that's actually quite simple. Also, it's self-service. The only thing you need to do to deploy a project is create a repository and enable CircleCI. And yeah, that's really key to innovating. It's also cheap. And I don't want to say that in the way that it's like it doesn't cost a lot of money to host things. Well, I mean, it still costs money, but it's cheap to try things out. It's cheap to create new instances, to create new environments. And that's really key to make it to make innovation possible, because if experimentation was expensive, then we probably wouldn't be experimenting as much. Also, it's customizable. So if there's anything in there that you don't like, hey, you can change it. If you, for some reason, you have a very old project that needs to run on PHP 5.5, it's possible. And at the same time, if you want to try the latest beta version or alpha version of any part of your stack, you can also do that. So you can customize any part of the process. Also, it's fast. Not only in terms of like the speed of the deployed environments, but also much more in how quickly you can deploy code, how quickly you can try out new things. And this is really the speed that matters. This is how quickly can we just work through new projects, new functionality, and really focus on the things that bring value. Also, we have tested deployment. It means every time that you push something, you're testing not only that your code works, but you're also testing that your infrastructure around the code works. And so you don't end up with these situations, for example, where which we had on a couple of projects where you want to change to a new Elasticsearch version. And the problem is that if you switch to the new version, then the old code won't work. If you switch to the new code, then it's not going to work with the old Elasticsearch version. So pretty much you need to have some downtime to do both steps at the same time. And with this system, we actually have both the provisioning of the infrastructure and the deployment of the code that are tied together. That means that we can very easily move forward, upgrade our infrastructure, and really keep things up to date. It can also be hosted everywhere. And then in terms of actually the concrete steps to get started with a project, what you do is you clone our Git repository, push it to a dedicated repository within our organization. So if you try this outside, it's not going to work because you're going to be missing some credentials. But yeah, for a colleague that would simply be cloning this repository, then run composer install and commit the log file, run yarn install, commit the log file. This is the same thing as any other hosting infrastructure, so there's nothing specific here. Also install your site locally and export your Drupal configuration. So if the configuration is there, it's actually going to be loaded automatically when the site is deployed. We also automatically install Drupal, and we also have the possibility to load a database dump at the same time, or well, alternatively to load a database dump. And then the last thing to do is enable CircleCI, and you log in to CircleCI with your GitHub credentials. So if you're part of the organization on GitHub, you automatically get access, so we don't spend a lot of time actually making sure who has access to what. And that's, yeah. And then you have a running installation that has been deployed. So, yay! Everybody was happy. But, well, I guess I need to, well, I mentioned that one of our values is honesty, and so I think I also need to give you the more honest version of how things work. So actually we built this thing, and it took some time to figure out how the different pieces fit together and how we do certain things. But we actually got something that was working quite well. We still have had a few points that were kind of open, kind of like sharing of volumes between different hosts and things like that. But we actually had a proof of concept that was actually working very well. And so we decided to try this out with different projects. And we deployed new projects, we deployed existing projects. Everything was working fine. And we said, hey, okay, great. Let's try this with client projects. And we had one project that was actually ideal for this type of infrastructure. It's one project that has a Drupal serving as a content hub. Then in front of it, there's a Node.js middleware, and then there's a React application that also has some server-side component, also based on Node.js. And so we have this set of applications that are, that all work together, connect to each other. And yeah, we deployed this, hey, within like a couple hours of figuring out, hey, how do we do this? And actually the Node.js middleware was actually built by another vendor. And so we also had to spend some time figuring out how they did certain things. But yeah, it really worked. And then as we started working more on this with a team, we ran into some issues. With a lot of different branches in parallel, things started to sometimes be slow and break down. The deployment would fail just because there was some issues. Or it would just time out because things would take too long. And we realized that the cluster was having some networking issues, and yeah, it caused some issues and caused some pains, some pretty big pains actually for the project development team. And if there's one thing that we really learned from this experience, actually test your infrastructure. Really, don't only do a load test and just try things out like that, but see how many concurrent deployments can you do? How many Drupal sites, standard Drupal sites, could you be running on that cluster that you already have? So that you have some benchmarks, like test limits. What happens if one of your nodes has networking issues? Try out all these things. And I think we were like a bit too optimistic at first. When things were working, that we would assume that they would keep on working. And I think this is one of the things that we would really recommend to anyone who is trying out this type of approach. Really spend the time to load test, to like put your infrastructure and your processes under load so that you get an idea of like how could this fail and what are the bottlenecks and what should you do to address those problems. Because when these type of like the hosting infrastructure that you're using during the development process is not available, of course this is affecting you. This is really affecting the work of your team. Then the next surprise was actually we have a very good relationship with the people from Kontena. Their office is in Helsinki, not far away from our Helsinki office. And yeah, we had a meeting with them, and it turned out that it's a good product, but they're not really interested in maintaining this product further. They're moving to a new solution called Kontena Pharos, and it's actually a like managed solution for Kubernetes hosting. And so they're pretty much leaving letting the open source project exist, but they're not going to be maintaining it, which is a bit of a drawback. And also the hosted solution that they provide for the hosted masters, this is also something that they're not going to be maintaining. And at this point we were like, well, do we really want to base our whole new infrastructure based on a project that's open source project that's not going to be used? And so we looked around, and the pretty obvious solution was to work with Kubernetes. And actually Kubernetes, it's not the same thing as Kontena. It's not a replacement. Kubernetes is very low-level API to manage all kinds of services and pods and stateful sets and deployments and so on. But it doesn't have this notion of here's a stack, here's an application. And so we had a look at the different alternatives, and there are many alternatives. And the one that we ended up settling on is actually a solution called Helm. Funnily enough, the guy who created Helm was also one of the guys who wrote one of the early Drupal books. There's some community connections there. With Helm, instead of using stacks, you have charts. They're kind of similar, but not exactly the same thing. So a chart is actually a bit more flexible, a bit more extendable. It's also possible to install a chart that's not in your code base, so you have a chart repository. And this is actually something that worked out really well for us in terms of the types of possibilities that you have. The charts, they don't hide any of the underlying Kubernetes logic and configuration. It just makes it easier to manage it. And so that means that you need to get familiar with these concepts like pods and stateful sets and deployment and ingress and services and yes, so it's actually quite complex. But with the experience that we had with Kontena, looking at all of these different concepts, we really realized that, hey, these are concepts that are addressing the exact needs that we have with in this hosting infrastructure. Persistence volume claims, for example, something that's actually quite difficult to handle. It's really nice to have a system that has a set way of handling these types of things. So yes, it's more complex, but this complexity is not just for the sake of complexity. It's actually based on industry experience. Also, it's industry standard. It's used pretty much like everywhere. And it's really interesting that I heard this opinion quite a few times, that even if Kubernetes is not the best container orchestration solution out there, it's the one that has the biggest impact because it has the most mature ecosystem around it. And this is really something that's not to be understated. Having a good support for everything that you need, from monitoring to logging and different solutions. So actually being the industry standard really brings you something. It's open source. It's has a hosted service on all the cloud providers, but you can also host that yourself if you're so inclined. And this open source aspect is really important because we want to be active citizens of the open source community, the same way that we have been with Drupal, when we talk about infrastructure, we want to do that. One more lesson, delegate storage. Most of the issues that we have actually been related to storage, so either file storage or database storage. And this is something that we knew from the start. It's kind of like best practices in container-based infrastructures. Don't put your persistence data in containers, because containers are meant to be stateless. They're meant to be volatile, that you can just instantiate them and kill them without notice. That doesn't work with data storage. So we have been planning, like when we get to a production setup, that we actually want to delegate the storage to hosted services like RDS, or like pretty much every platform has some kind of like hosted database service, hosted files, and so on. But yeah, this is something that we see that it makes sense for production, and maybe we also want to use something like that for the development environment. So in the end, the question, is this right? Are we doing it right? Is this the right decision? And I think, well, yes, maybe. We'll see. We don't know, and it's a work in progress. But we see that this concept of combining multiple pieces together, multiple services that actually each of them has a very dedicated purpose, this actually works quite well. We are not 100% sure that each of those components are the ones that will be final. And actually, we want to have an infrastructure that evolves over time. So we know that the components that we use will become obsolete someday. And instead of having, like, betting everything on a specific setup, we want to have a good concept of how things fit together, and then between those different components, make sure that we are using open APIs, open standards, so that it's as easy as possible to replace the individual components and have an infrastructure that evolves over time without ever getting outdated. And so, is it right? I don't know if it is right. It's definitely not right for everyone, but it's something that works for us. And I'm really happy to continue working on this, and of course, we'll share everything that we have. Before we go into questions, I just want to thank our sponsors. This conference wouldn't happen without all the sponsors, the big ones, the small ones. So thank you to everyone. And if you have any questions, let me know. Yes?
You said it's possible to input database types into those staging systems. How do you deal with that?
That's actually one of the things that's a bit tricky, because you don't really get SSH access to a container. Oh, yeah, sorry. The question was, you mentioned that it's possible to import database dump into this staging system. How do you do that? Yeah, so it's a bit tricky, because according to best practices, you should not get SSH access to a container. That means you can't use rsync or SCP to kind of upload things. What you can, however, do is you can actually use the you can execute commands, and you can also execute, for example, a database import command and pipe the database dump that you have locally into that. So it's possible. It works. It takes some getting familiar with this. This is also something that we want to improve, because it's not a very developer-friendly solution. So we have a temporary solution for that. The solution that we'll probably end up using is having a sidecar container that has actually SSH running for specific environments. So we don't want to run this in production, for example, where you can SSH into that and then use the same volume that you share with the container running your application.
branch instances, like where do you get like or what is like the files and database that you use for that? Like,
so there's different approaches. One of the approach that we can take and that either you start from scratch every single time, and that works for some projects that are very like application-like and don't really rely on the content. But for many Drupal sites, that's not a practical solution. One of the things that we can do is have a cron job on the master environment, actually from CircleCI, that's getting triggered, and then once a day we take a database dump, save it somewhere, and actually use that dump to start new environments. This is actually an interesting place for GDPR stuff to come in, to say, actually, we want to export a sanitized dump, and that's the only dump that developers have access to, and that's also the dump that gets used on other environments. So you don't end up spreading sensitive data. That's one of the solutions. So I actually both work quite well, and there's also some situation, for example, when you have very large databases, you don't want to do that. So as part of the same sanitization process where we remove sensitive data, we could say, actually, just keep the last 1,000 nodes, and everything else besides that, don't export it. We haven't actually implemented that yet, but yeah, that's the kind of setup that we want to use, because I think the type of system where you just automatically get the dump from the parent environment, for example, when you create pull request, that's practical, but also it has some pretty big limitations, and yeah, you don't always need like a terabyte of data on every environment. Yes?
Your images are completely custom or built on Wattby or some other?
Actually, we started with using Wattby images as the base, and so we use this as a base image and then copy our code into that. What we realize is that the Wattby images are not exactly compatible with how we want to do things. So they're much more planned towards actually just get Drupal and run Drupal as an application and just configure everything without using the whole configuration management and like a more kind of like software development, software and engineering based approach. So we use that as a start, and we're going to be moving away from that so that we have more control. And one of the points there is also optimization of size, because the Wattby images already contain a Drupal code base, and then if you want to copy your own code base into there, you pretty much end up with a Docker image that has 2 layers, both of which contain the entire Drupal code base. And yeah, so we really see that like the biggest bottleneck that we have in terms of in terms of speed, it's really the size of the code base and how that gets transferred. So even for Drupal core, for example, we skip all the test folders, and that's already saving like 2/3 of the size of Drupal core. Well, actually, all the environments, like their configuration is based directly on the branch. And so the only thing that we need to do is kind of teach our teams not to create like 500 branches and leave them open. And yeah, at the moment, this has not really been an issue, but we know that we'll need some kind of like automated kind of cleanup system to actually say, hey, any branch, like any feature branch, something that's called feature that's been open for over a specific amount of time, we just kill the environment. We go from we make the assumption that these feature environments don't necessarily have like essential data. So it should be possible to remove them if there are too many. Okay, well, if you have any questions, or if you want to see anything, feel free to come talk to me either now or maybe later at the Wunder booth. And yeah, great to hear any feedback. So, thank you.